We head back to algebra. Now we're going to put the word limit to something that you've done and you probably don't think about. It's limits at infinity. In algebra, we call it end behavior. So in algebra, if I had a polynomial, we would say, I'm interested in the arrows. That's what end behavior is. And we don't use the word limit, at least I don't, in college algebra. We normally say, well, x kind of gets very, very big or goes to infinity. What does y do? Well, from the graph, it's going up to infinity. So as x increases, y increases. And I'm only interested in, if I'm looking at infinity, what happens on the way out. What does in the middle doesn't make any difference. You can do all kinds of stuff in the middle. It's only the arrows. Here, as x goes to negative infinity, I notice that y is going down, so it's going to negative infinity. It's called end behavior. If you were in my class, we did top, top, bottom, 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 top, top, bottom. So that says this is coming in from the bottom and going out through the top. If I were looking at this guy, he would be top, top. He's coming in from the top and going out through the top. That's where the arrows go. Now we're going to put the calculus or the limit behind the whole idea of end behavior. And that's limits at infinity. So the x is very, very big. Don't care what is happening as x goes to 1 or x goes to 5 or x goes to 9. As far as we're concerned, it's just getting huge. For huge values of x, what's y doing? Limits at infinity, end behavior of the function, which is what I would call it, if the value of the function f of x approaches a number L, x increases without bound, we write the limit as x approaches infinity of f of x equals L. If it's going to negative infinity, you would write the limit as x goes to negative infinity of f of x equals m. Now we're talking about numbers. If we're talking about numbers, what in the heck are we talking about? That goes back to the whole idea of horizontal asymptotes. As x goes to infinity, y is going to be bounded by L. It's a boundary. It's either going to be a ceiling or a floor. And as x goes to negative infinity, and we'll do a second one here and let this be m. As x goes to negative infinity, y would be bounded by m. They're horizontal asymptotes, so that's what they're talking about here. They're horizontal asymptotes. Now here, these are not horizontal asymptotes. That means you can have limits that go to infinity, either plus or minus. That's what I mean. There's a difference between does not exist and undefined. Now what's the key? The key is this right here. As x goes to infinity, any number, any constant over x to some power, or negative infinity of x to some power, you get 0. Well, why is that? A constant divided by plus or minus infinity, or a constant divided by plus or minus huge, huge number. Is going to be equal to 0. Because the denominator gets so big that for all intents and purposes it's 0. Now 1 over x takes longer to get there. This is a piecewise function. Let me turn him off just in case. There's 1 divided by x. And I probably want to set the table. Division by 0 is an error, right? And that becomes something else, and the further along I go and the bigger x gets, the smaller y gets. Now this is going to go to 0 really slowly. But notice it's getting smaller and smaller and smaller and smaller and smaller and smaller. And let's make this a little faster. I don't know about you, I get impatient. I start reading something like online or something like that, and it's kind of interesting for a while, then I said, that gets boring, and I move on. This went really fast. Let's start that at 0. There we go. Notice smaller. Then suddenly there's 2 zeros in front. Now we're going to shortly have 3 zeros. Now notice, that says e to the negative 4. That's scientific notation. That would be 9, that doesn't write. 9 times 10 to the negative 4. So that says this is going to be 0.1239. So now I've got 3 zeros in front. So for all intents and purposes, to the nearest tenth it's 0, nearest hundredth it's 0, nearest thousandth it's 0. Out of this 10,000ths position, as you get that. And I'm only where? At x equal 33. That's not a big number. So that says you have a constant over x to any power, it's 0. So for me, I look at a constant over plus or minus infinity. So if I would say 1 divided by infinity, to me, it's 0. Because it's a big number. 33 is not a big number. The question for us, is it going to be a plus infinity or is it going to be a minus infinity? So here we go, limits at infinity. We're going to go back to college algebra. In the world of polynomials, if I were to look at who's going to affect the end behavior of all of these terms, who would it be? What term basically is in control of the whole thing? The cube, right? He's got the highest power. In college algebra, we called him the power function. This makes your life very easy, by the way. And this is the term with the highest power. So the controller in this case the power function, is negative 3x cubed. That says, well, after a while, if x is very large, like a trillion cubed is so big that a trillion squared doesn't matter, or a trillion doesn't matter, and 1 doesn't matter, because the numbers are so big. So that means I want to find the limit as x goes to infinity of negative 3x squared, cubed, excuse me. Boy, if it's square, I'm going to have a different problem. Well, what it's going to go to is negative 3 times infinity cubed. And what might you think infinity cubed might be? Infinity. Negative 3 times infinity cubed is going to take it to negative infinity. Infinity just says very big, not a number. So what that says is, as x goes to infinity, y is going down to negative infinity. And if I take the limit as x goes to negative infinity of negative 3x cubed, I didn't mean to put those parentheses in, it's going to go to negative 3 times negative infinity cubed, which is negative 3. What's negative infinity cubed? Negative infinity times negative infinity times negative infinity is negative infinity. And negative 3 times negative infinity is going to be negative times a negative is a positive. Now that says as x goes to negative infinity, y is going up. So if I were to graph it, it starts at the top, does what it's going to do, and goes out through the bottom.
So I don't understand why we only took the negative 3x cubed and not the rest of the problem.
Well, and that is because that if I'm thinking about, well, Bill Gates, he's only worth what? About 81 billion, maybe 60, I think maybe 69 billion, that's, or 70 billion, right? If I cube 70 billion, 70 billion cubed is a big number.
Right.
How does that compare to 70 billion squared? If you're Bill Gates and you've got 70 billion cubed, how does that compare to 70 billion squared?
It's a big difference.
Big difference. But that may not make much difference to him. And if I look at 70 billion compared to 70 billion cubed, that's not going to make much difference either. And if I look at 1 compared to 70 billion, it makes no difference whatsoever. So the highest power controls what's happening at the end. Why? Because the numbers are getting so big, everybody else slowly drops off. So I walk up to Bill Gates with $1 and he laughs at me, right? That doesn't matter. I walk up to him with $1 squared. Well, let's make it interesting. With $10, he still laughs at me. 10 squared is 100. He still laughs at me, right? 10 cubed is 1,000. He would still laugh at me. Why? Because it compared to what he has, it's nothing, it's small change. It's a lot of money to us, but not to him. So when you're looking at a polynomial, it's that highest power that's going to carry the day. So what is it? It's 1 minus x, should have put this in ahead of time, plus 2x squared
I think that's just, she's saying that
minus
the,
3x cubed.
it starts with.
Well, it helps if I typed it in and it was in a place. 1 minus x plus 2x squared minus 3x cubed. There we go. There he is, and I've got him turned on, so I'm going to go to Zoom 6, Zoom Standard. Hopefully we'll get something. There he is. Notice, as x goes to infinity, y is going down. And as x goes to negative infinity, y is going up. And that's what in behavior is. It says, what's the behavior at the end? Where are the arrows? Where are the arrows pointing? The arrow pointing either up, or they're pointing down, or they're going to go flat. One of the three. If you're doing limits and infinity.